This is part 3 of our discussion on built-in, spatial, and custom functions. In this part, we're going to start with the custom function, which is an added plugin. Let's show you the worksheet that we're going to use. In that worksheet, we have my recommendation that you include the custom functions. I show you at the beginning of this series how do you include that one, where you should have it in the plugins custom functions available. And some of those functions, by the way, when you insert them, if you click in here, for example, and you click on FX, look for custom functions, and you find them add cases and so on. We start with the all functions except those that are repeated in matrix and vectors or complex numbers and so on. So we start with the function add. This is just an evaluation of a function. For example, I clear the X here to make sure that I don't mess up things, and I define a function f of X. And then by typing add f of X, Y, I'm going to type it over here. You type add parenthesis f of X spacebar comma Y, and you do control dot. Then you evaluate the function f of X by replacing X with Y, and you get that. Another example is shown in here, and that would be simply writing add f of X spacebar comma square root of S square spacebar plus 1 control dot. And so whatever I put here gets replaced for X, and that's what I get this result. Okay. If you use add f of X with two numbers, basically you're doing the evaluation like when you evaluate an integral. And so in the first case, you for example type add f of X spacebar comma, sorry, let's try again, add f of X spacebar comma A comma B, and then we do control dot, and what we'll be doing is evaluating the function at the upper limit B minus the function at the lower limit A. You can evaluate it with specific numbers, and we'll give you a numerical result. Then we have the ceiling function. The ceiling function simply takes the integer number right on top of this particular number, and it's shown like this upper bracket, right? If you use only one argument, simply the ceiling function. If you use two arguments, it will try to find the nearest integer larger than X that is multiple of the second argument. For example, 12.3 to a number that's multiple of 2 that's larger, immediately larger than 12.3 is 14. Okay, because if we don't use that second argument, it will be 13, but the 13 is not a multiple of 2, so you get 14. And so if you try to find the number larger than 12.3 that is a multiple of 3, the closest one will be 15. I haven't used this type of ceiling function much, mostly this one. Here we have something called order of magnitude. To tell you the truth, I'm not very sure what this means, but you can explore on your own. Go for the for function, which is giving me the lower level, the lower number, integer number. Similar to ceiling, but ceiling is at the top. This is the bottom, and also you can find a bottom number that's a multiple of 2 or 3 or whatever number. This comparison triad is probably useful in programming. And basically what you have to keep in mind is that GE means greater than or equal, GT means greater than, LE means less than or equal, LT means less than. And so you have greater than or equal, greater than or equal, greater than or equal, greater, and so that corresponds to these symbols. And here are some examples. I invite you to explore them. I haven't used those much, but they will probably be useful in programming, so I'll give you these ideas in here. Get type argument. For example, if I have X defined as X equal 2 and Y not defined, get type of X will give me it's a number, get type of Y is unknown. This is obviously a vector, but it's defined as a matrix. And this is a string. So it will give you the type of a particular object in Math Studio. This is probably also useful in programming. Chronicle delta. Chronicle delta is a two-dimensional tensor. It's useful in applications of tensors like in fluid mechanics, electricity, and so on. And it's so that when I is equal to j, delta ij is equal to 1. And if I is different from j, delta ij is equal to 0. So this basically defines an identity matrix. If you think of this as elements of a matrix, the whole diagonal when I is equal to 1 is equal, when I is equal to j, sorry, is equal to 1, but all the other numbers are 0. So if I type like identity 2, or let's try 3. If you can see, this is basically what delta ij means. When I is equal to j, then the numbers are equal to 1. Anyway, off the main diagonal is equal to 0. And so there you got it. Delta 1 to 0, delta 3 to 0. But if I type Kronecker, you have to type the word Kronecker. And then say 2, 2 is equal to 1. Max is the maximum of a list. I mean, this could be like a simple listing of numbers. It could be a vector. It could be a matrix. It could be a system. What is called a system is this symbol right here. That's the main difference between this max and the lowercase max that comes with Math Studio. Similar for min. And we have order of magnitude, as I mentioned. I cannot give you a lot of detail on this because I haven't used much. So we're going to skip that. There's the percentage when a number is represented as a percentage. If you type perc of 58, for example, that's 58%. I think this is just mostly for representational purposes. Per mil, that means per thousand. Per mil, say 78. 0.78%. Unknowns variable returns a vector of unassigned variables containing variables if nowhere not found returns 0. I haven't used that much too. You could explore if you want. And this is units of measurement. This is very similar to the units of function that we presented in the last video. It will give you for a particular length the unit of length in the SI system. The conjugate, this is a great function because conjugates show up a lot in complex numbers. So if you type conjugate with uppercase conjugate and then type a number, it will give you that bar at the top. That's the typical symbol of conjugate. If you do something like say x plus I times y and do control dot, since I declare x equal to 2, so I'm going to do something here. I'm going to do clear x equal. See, when I do that, then my conjugate is simply the same complex number with an imaginary part negative. Here are some examples. If I declare z as my complex number right here, the conjugate is such that the real part is the same, but now has been numerically expanded, and the imaginary part is negative. For matrix and vector, we have the function diagonal, diag. If you have a matrix and apply diag, it will give you a matrix that preserves only the main diagonal. If you have a vector and you use diag, it will give you a matrix which will convert this vector into its main diagonal. Zeros, uppercase, will give you, if it is a single integer number, it will give you a vector. If it is two integer number, it will give you a matrix. Same thing with ones, but this will be filled with zeros, this will be filled with 1. Again, this will be also very useful for programming. Then we have bilinear interpolation. This is in an earlier video I talked about interpolation of two vectors, x and y. But now suppose that you have a surface. So you have a vector value of x and a vector value of y. So that every entry in this matrix corresponds to a certain function, we call it z. So that this z equals 6 corresponds to x equal 2 and y equal 2. Right. So suppose now you want to interpolate the value of z if x is equal to 3.5 and y is equal to 2.5. Those two values are not listed in the vectors of x and b. They are in between though. 3.5 will be between 3 and 4, and 2.5 here will be between 2 and 3. So we're looking at the 3 and 4, basically interpolating between these four numbers. And so when you use the function bilinear with vectors x, b, y, b, for matrix Z, 3.5, 2.5, we get the value of 5, which would be sort of the average of these four values. We can check that if we do 7 plus 6 plus 7 plus 0 and divide by 4, we get 5. So that's the interpolation. Now, in this case, because the numbers for x and y are separated by 1, the average works out fine. If you had different spacing between the numbers, then it's going to be slightly different. But this is the basic idea. And here's another example. The vectors x, b, and y, b must be in increasing or decreasing order. In this case, x is in decreasing order and y is also in decreasing order. X is in increasing order, but y is in decreasing order. Here, y is in increasing order, x in decreasing order. But the interpolation works fine. You can check it by looking at the numbers in these examples. Finally, the functions mat to sys, sys to mat. Mat to sys, if you have a matrix like this, it will simply split all the numbers in a certain order, like 2, 4, 2, 4, 5, into a system. Mat to sys, if you use the subindex 1, or the suffix 1, then it will convert only the exterior matrix into a system, preserving the matrix inside. Sys to mat, when you have a system, you do sys to mat, it will convert it to a matrix. If you do sys to mat 1, it will do the same effect. I invite you to explore all those functions for you for a custom function. But I particularly find useful for programming the function zeros and 1. Function diagonal may be useful too. Conjugate is very useful. And out of here, well, for some applications, Chronicles Delta. These could be useful for programming, as I mentioned. And then you have the ceiling and floor functions, as well as the add function that could be useful for the custom functions plugin. And that with that, we're going to stop this video right here.